Hi, I'm Jordan. Vantablack is the darkest artificial substance that we know of. It is made out of vertically aligned carbon nanotube arrays, and it absorbs 99.965% of radiation in the visible spectrum. It is so black that once an object is painted in Vantablack, you can no longer see its contours. But why is it so dark? Electromagnetic radiations refer to waves able to transport energy through space. This includes microwaves, radio waves, infrared, ultraviolet, visible light, X, and gamma radiations. All of them have different wavelength, as the distance between two waves measured in nanometers, and a frequency which describes the number of waves that pass a fixed place in a given amount of time, measured in hertz. Radio waves are the longest, and gamma rays are the shortest. Visible light has a length between 380 and 750 nanometers, and its frequency is between 430 and 770 terahertz. Visible light is also known as the visible spectrum. In 1672, Isaac Newton publishes a series of experiments, in one of which he analyzes the rainbow. He took a transparent prism and exposed it to light, noticing that it refracted the rainbow's colors: red, orange, yellow, green, blue, indigo, and violet, whose order is based on ascending wavelength. These colors together make the whole of the visible spectrum, as in the range of pigments our brain can perceive and distinguish. But color isn't as simple as it seems. Atoms inside a molecule can be in motion while the molecule itself is moving. This is defined by molecular vibration. Everything has molecular vibration and a frequency to which the molecules shake. When a wave hits a surface, the wave can either be absorbed or refracted. To be absorbed, the surface must have the same frequency as the wave, and the energy turns into heat. However, if the surface and the wave have different frequencies, then the wave is refracted. When visible light hits an object, the object can absorb many different frequencies. If it absorbs all the frequencies, it appears black. If it refracts every frequency, it appears white. If it refracts green, it appears green, etc. Our retina captures the light, specifically by rods and cones. They are responsible for color perception. Rods can only see black or white, whilst cones can see red, green, and blue, making the RGB system. Just using three pigments, the brain can rebuild the whole of the visible spectrum by color addition and color subtraction. Color addition starts with the three primary colors. When they meet, every combination has a different outcome, therefore a new color. An additive secondary. When they all meet, they create white. So to the human eye, white is the sum of all colors, as all visible light gets refracted. Whilst in color subtraction, you start with the three additive secondaries and get the three primary ones. When all the secondaries meet, they create black. So to the human eye, black is absence of color, as no color gets refracted, but all visible light gets absorbed. Color addition and color subtraction take place in the brain. The cones send messages containing what they see to the brain. For example, if you see a yellow object, your cones will be seeing a little bit of green and a little bit of red. This is also the secret behind pixels. They can be red, green, or blue, and as long as they are small enough, your eyes can see a color sum or subtraction. You could technically say that what we see and how we perceive color is all an illusion. Pigment perception can be poor in humans. An anomaly reduces sensitivity to red, the other anomaly reduces sensitivity to green, and red anomaly reduces sensitivity to blue. They are examples of partial color blindness, which reduces the visible spectrum to an even smaller range of perceivable pigments. Many animals have different visible spectrums and see the world in many different ways. Some are even completely colorblind and can't distinguish any color. Some animals can even see beyond our spectrum, such as butterflies and bees, which can see ultraviolet. So going back to Vantablack, the reason why it's so dark is because it absorbs nearly all light, and cones have no refracted light to work with, therefore see nearly complete darkness. And as always, thanks for watching.